Hello, welcome back to the channel Farmer Training Solution. So today, now shall be discussing phytochemistry and then of course some common synthetic pathways for the synthesis and the chemic pathway. So what is phytochemistry? Of course, phytochemistry is a study of the constituents derived from plants, the active metabolites. We have primary, these are essential for growth, and these are the first development of the plant, and these are the first products of photosynthesis. We have carbohydrates, amino acids, and fatty acids. We have the secondary metabolites. These are not essential for sustaining the cell of plants. However, they are derived from primary metabolite pathways. Examples such as glycosides, tannins, volatile oils, and alkaloids. And those are the ones who have medicinal importance. Now, photosynthesis, I was supposed to describe photosynthesis, but let me briefly talk about photosynthesis. Of course, photosynthesis is a process. This is a process. By which carbon dioxide in atmosphere is converted into sugars by growing plants. Even from primary, we've been discussing photosynthesis. Of course, it occurs in the chloroplasts. So, of course, we know. There are two stages of photosynthesis. We have the light stage and the dark stage, or the one which is called the Calvin cycle. Now, with the light-dependent stage, of course, it occurs in the thylakoid. This is very important. Objectives can come based on this. And of course, it requires light. Two photosystems are involved, 1 and 2 photosystems. Now, ensure there are those diagrams which can be used to represent this electron flow. Of course, in cyclic electron flow or photosphorylation, it involves photosystem, one which absorbs light, and of course the end product is what is ATP. ATP. And of course, in non-cyclic electron flow, here has to be the word non. The non-cyclic electron flow or the non-cyclic photosphorylation, it involves photosystems 1 and 2, and of course chlorophyll, all of them are absorbing light, and the electrons flow. The flow of electrons is non-cyclic and involves photolysis of water. The end products are oxygen, ATP, and NADPH. Now, there are diagrams which show this. Those diagrams, I wish you could download them and read them. Those diagrams for cyclic electron flow and encyclic electron flow. Because it is good if you draw a diagram after each, and that you really show how electrons are flowing and how the end products are being formed, especially with non-cyclic, where you are involving photolysis of water and leading to production of oxygen. Now, the light independent stage or the dark stage of photosynthesis, of course, it utilizes the energy from light stage. ATP, NADPH, to convert CO2, carbon dioxide, and water into simple sugars. It takes place in the stroma of the chloroplast. The other one takes place in the thylakoid of the chloroplast. Of course, an enzyme rubisco is used to ribose biphosphate carboxylase, and of course carbon dioxide is utilized. The stages in this presentation, I just described the summary of the cycle, but there's a longer summary. A longer cycle. Carbon fixation, reduction, regeneration, the starting molecules, and then carbohydrate synthesis. Now, of course, this is a summary of the dark stage. There is a longer cycle which you should look for. It's a summary. We have carbon dioxide here, fixation by ribose by rubisco, the enzyme, to form 2-PGA. This is phosphoglycerides. Then you form these ones, This is now the fixation, reduction, carbohydrate synthesis, and regeneration, the stages. Now there is a longer cycle, which you have to know. This is the fixation, reduction, regeneration. However, also carbohydrates are formed. The enzymes are very important. Enzymes on each, and in the longer cycle, it is there. It's just a summary. You can either represent it in a cycle form or in words. Now, let us first look at the different plants which fix carbon dioxide. We have the C3 plants. Of course, these are green plants that follow the Calvin cycle, and then of course ribose 1,5-diphosphate combined with CO2 catalyzed by Rubisco to produce 2 molecules of 3-phosphoglyceric acid. However, there is no future to combat photophosphorylation. There is no future because again Rubisco can act on oxygen. Hence there is energy lost here. I'm sure you know what I'm meaning here. There is no future to combat photophosphorylation. Hence Rubisco also reacts with oxygen. Plants examples we have soybean, rice. Now for CAM3, for C3, sorry, for C4 plants or the cabbagrass, ensure you know how to describe them. These ones involve first forming mallet, later pyruvate. Ensure you know how to describe the C4, and then the crosserant acid metabolism or the CAM plants. Ensure you know how to describe these ones. The spore, this one also, these are mostly desert plants, cactus and lilies. Ensure you know examples and explaining this. I don't have to go through all of them because remember this is a short presentation, at least to motivate you to go and read further. Of course, you should know that this is the first stages of carbohydrate utilization, because it is these stages that produce the components of which are required in the production of secondary metabolites. Let me briefly talk about the chemic pathway. Of course, this is a route which occurs in plants, fungi, and leads to production of aromatic amino acids such as phenylalanine, tyrosine, and tryptophan. The pathway is like this. This is the pathway. All these ones are products of what? Either the Calvin, and we produce tryptophan and tyrosine and phenylalanine. So again, this has been a short presentation. I'm sure you can to guide you in your reading. I always remain Wilson. Thank you for listening to me. Subscribe to the channel in case you haven't subscribed. You can contact us for more information and farmer training solution. Thank you very much.